Today we are going to start talking about how we can graph linear inequalities with shortcuts, right? So lots of you said to me, I can graph in y equals mx plus b form, and that's great. We're going to talk about that. But one of the ways that we can graph linear inequalities with an equation with a shortcut is in standard form. Standard form is when it says ax plus by equals c, where a, b, and c are all numbers. They can be any number they want to be. So we can identify sort of standard form. The sort of trait that we see is that x and y are on the same side of that equal sign. We use standard form to identify two things. Okay, one thing that we can find is the x-intercept. We already talked about that in the last unit. That's where it crosses the x-axis. And to find the y-intercept, right? We know the y-intercept is where we cross the y-axis. Now, we have also learned that if we are talking about the x-intercept, we know that the y value equals 0, right? We know that's an ordered pair x comma 0, which means if we want to find the x-intercept, we are going to be able to substitute 0 in for the y value, because we know at the x-intercept, y has to equal 0. So for example, let's say we are given 4x plus 2y equals 12. We know that this is in standard form because we're in the form ax plus by equals c. If we want to find the x-intercept, what we can do is we can replace y with 0, right? I'm substituting y in for 0. Now we know 2 times 0 is 0, so this just becomes 4x equals 12. And then we can just solve this as a one-step equation. We undo multiplication with division, and so we get x equals 3. Okay, this tells us that our x-intercept is 3. All right, we also know as an ordered pair, that would be 3 comma 0. Now we know the flip-flop sort of that to be true, right? That if we want to find the y-intercept, we know when we are finding a y-intercept that it has an x value of 0. So if we want to find the y-intercept, we are going to substitute 0 in for the x value. So again, if I'm looking at the exact same equation, so I'm looking at the same one I had above, before I was substituting in 0 for y to find the x-intercept, now I'm going to substitute in 0 for x to find the y-intercept. Right, the variable that we have left is the intercept that we are finding. So I know 4 times 0 is 0, and this just leaves me with 2y equals 12. Can undo multiplication with division. And this tells me that my y-intercept equals 6. Now again, we really also know that that is 0 comma 6. Now, if we find these two things, which are relatively simple to find, we can then graph 4x plus 2y equals 12 by plotting on our xy plane, plotting on our coordinate plane, an x-intercept value of 3. So I'm going to go on my x-axis. This is my x-axis, and I'm going to go to 3, and I'm going to make a point, right? That is the point 3 comma 0, my x-intercept. And I'm going to go on my y-axis. This is my y-axis, and I'm going to find the x-intercept at 6. That is the point 0 comma 6. Those 2 points will make my line. Okay, so once we get the hang of this process is actually a lot quicker than having to go all the way through and solve for y and make a table and plug in points. But the catch is that it only works if we are in the correct form. Okay, so let's go through and look at some examples. So if we look at example 1, x plus 5y equals negative 10. Okay, if we want to find our x-intercept, we are going to plug in a y value of 0. So I'm going to say x plus 5 times 0 equals negative 10. 5 times 0 is 0, and so this is going to tell me that x equals negative 10. I don't even have anything to solve. This is telling me that my x-intercept is negative 10. To find my y-intercept, I'm going to plug in an x value of 0. So I'll say 0 plus 5 times y equals negative 10, right? My 0 just goes away. This is something I can solve. And so I'll get y equals negative 2. So again, if I want to graph this, I'm going to go on my x-axis to negative 10. There's my x-intercept. And on my y-axis to negative 2, there's my y-intercept. And then these 2 points are going to make my line. Right? We're making sure that that's a line that goes all the way across the coordinate plane. Those are all the points that would make that function rule true. It's just a quicker way of finding it than making a table. Now, we can even shorten this up a little bit more because we've probably started to realize every time we plug in 0, it just goes away. So if I'm looking at number 2, 5x minus 10y equals negative 35, and I want to find my x-intercept, right, I am going to say my y value equals 0. But I know if I plug in 0 for y, 10 times 0 just becomes 0, and so I'll get 5x equals negative 35. Just don't lose your negatives. So my x-intercept is negative 7. And if I go to do my y-intercept and I plug 0 in for x, I know that this is going to become 0. Now don't lose your subtraction, right? That's telling us that that 10 is negative. So I'll have negative 10y equals negative 35. Now, whether you choose to leave this as a fraction or a decimal is up to you. It's either way that you can get this on a number line. And I think for the majority of you, you would prefer a decimal to get this on the number line. In fact, we're going to talk about this as we go throughout the units. One of the biggest flaws of standard form is that if we get a decimal as one of the intercepts, we have to kind of approximate it on the graph. And we've talked about the fact that we don't really like to do those fraction or decimal approximations on the graph. But unfortunately, in standard form, our hands are tied. We do not have another option, so we're going to do the best that we can with it. So we're going to say our x-intercept on our x-axis is negative 7. And our y-intercept on our y-axis is 3.5. So I'm just going in between 3 and 4. And there is my line. Now our next one might seem a little weird because we don't have an x value at all. And we've actually already talked about how to graph this with a table, but we're just gonna look at how we can also think about this in standard form, right? This already tells us what y equals, right? Y equals negative 5. This has no x value in it at all. So because it has no x value, it has no x-intercept. I really don't need that line there, sorry guys. Which means this graph cannot touch the x-intercept, the x-axis. So if this is our x-axis and we cannot touch it, we need a line that is parallel to it, which means I'm going to make a y-intercept of negative 5, and then I need a line that will never touch the x-axis. And so I will get a horizontal line. Now, what I would like you to do is pause this and take a couple of minutes to try and do number 4, 5, and 6 by yourself. Once you finish, press play again, and I'm going to quickly go through the answers. So at this point, you should have these graphed, so I am not going to take as much time to go through them. I'm just going to do a quick run through. right? On number 4, we should have plugged in a y value of 0 and said 12x equals 24. And we should have plugged in x value of 0, which gives us negative 8y equals 24. And so we have an x-intercept of 2 and a y-intercept of negative 3. Our next one, when we plug in 0 for y, we have 5x equals 25. Now again, you can plug in 0 and do all the work every time. So you can, for your next one, say 5 times 0 minus 5y equals 25. You can do all that work every time. But just remember that 0 always multiplies with a 0 and cancels it out. And so we get an x-intercept of 5 and a y-intercept of negative 5. On our last one, number 6, this has an x equals 4, so we know our x-intercept is 4, but this has no y-intercept. So we are going to go on our x-axis to 4, and we are never going to cross the y-axis, which means we are going to have a vertical line. Now, if I was in school, we would go through with Desmos and check these lines. Remember how we went to desmos.com? And we typed in these equations and we saw what the graph looked like. But since I'm not there today, you are not going to be required to do that.